Hey class, Coach Corbin here. I'm at the dentist this morning and I won't be back until fourth period, but I wanted to make sure that first, second, and third didn't miss out on notes. Okay, Coach Baldwin has passed out the composite figures notes to you guys. These are the first two bullet points on the notes. Let's go ahead and fill them in. A composite figure is a figure that can be separated into regions that are basic plane figures. Sorry, my dog's squeaking the toy. Bo, come here. Stop. Okay, to find the area of a composite figure, we're going to divide up the regions and find each area, and then find the sum of those areas. Okay, remember sum means you're adding all of the areas together at the very end. Okay, fill in these blanks, and then let's look at the first example together. Here's example number 1. You guys see this marked on your paper. Okay, the first things the directions say is to separate the regions. So here's the first region I'm going to calculate, then the second region I'm going to calculate. Okay, I really recommend labeling them with numbers, that way your scratch work matches. It's going to help you keep up with it and help me keep up with it. Okay, for the first shape, that's a parallelogram, specifically a rectangle. So area equals base times height. Let's plug in the base. Remember, base and height always meet at a right angle. So that's going to be 23 times 12. So the area of the first region is 276 square centimeters. Okay, now let's find the area of the second region. The second region, it looks like there's only one set of parallel lines. Okay, so this is best classified as a trapezoid. The area, or the formula for the area of a trapezoid is 1/2 the height times base 1 plus base 2. Okay, let's go ahead and plug in our given information. It looks like here's going to be our base. Here's another base. Okay, but the issue is they did not give me the measurement for this base right here. Okay, what I'm going to have to do is look opposite. If this side of the rectangle is 23 centimeters, then base 1, okay, would be 23 centimeters as well. And base 2 they give us as 15. Okay, the last thing we're missing is the height to plug in. Okay, well, if we reevaluate the picture, this entire length is 18 centimeters. So if this whole piece is 18 centimeters and just this part right here is 12 centimeters, we can do 18 minus 12 to find what just this portion would be. And that looks like there's going to be 6 centimeters left. So the height of this piece is 6. Let's plug them all in and crunch the numbers. I'm going to go ahead and add these together. That's going to give me 38. And when you punch this in your calculator, you should get 114 square centimeters. Okay, so we have the area of the first section, the area of the second section. Okay, and the last thing I need to do is find the sum. So the total area equals 276 plus 114. And that's a total of 390 square centimeters. Okay. If you need to, you can pause the video and you can ask Coach Baldwin questions. Okay, number 2, it looks like we have a parallelogram and it looks like we have 2 semicircles. Okay, let's go ahead and break this up into our first region. We'll find the parallelogram. And then essentially, if these are both semicircles, we can find the area of the total circle and then add that all together. So let's start with the first section. Okay, this is a parallelogram, so area equals base times height. Remember that base and height are always going to meet perpendicular. So I'm looking for that right angle. The base, well, if this side is 6, if the radius is 6, then the entire diameter would be 12 or double. Okay, so it looks like the base is 12 while the height is 5. Okay, that means that the area of the parallelogram is 60 square inches. All right, then let's find the area of the circle. Okay, area of the circle is pi r squared. My radius is 6, so let's plug this in. 6 squared is 36. And if we want to give an approximation, we can punch this in our calculator and get that this is about 113.1 inches squared. Okay, so to find the total answer, or the total area, we're going to find the sum of these two. So 60 plus 113.1 gives us a total of 173.1 square inches. And I guess this would be an approximation since I rounded that answer. Okay, if you need to, go ahead and pause the video and you can ask Coach Baldwin questions. If not, we'll move on to the next example. Example number 3. Okay, it looks like in this picture we have 1, 2, 3 different regions. Okay, the first region looks like a parallelogram, more specifically a rectangle. Okay, so the area equals base times height. Okay, remember that base and height meet perpendicular. Okay, but we're actually going to have to figure out what the height is. Okay, the base and height are meeting right here. Well, the base is 9. Okay, but the height is a little bit tricky. We have that this whole piece is 26. Okay, another piece of information that we have is this 9 feet right here. Well, if you slide this 9 feet down, this 9 feet is essentially representing the radius of this circle. Okay, and if the radius of the circle is 9 feet, that means that this radius that I drew in is also 9 feet. We'll take a look. This radius is 9 feet of the 26 feet that we see out here. Okay, so I'm going to take my 26 units, subtract out the 9-foot radius, okay, and that's going to give us a height of 17. Okay, now I can continue this problem. Area equals base times height, so 9 times 17, and that's going to be 153 feet squared. Okay, so I found the area of the parallelogram or rectangle. Let's move on to the second region. That looks like a triangle, so area equals 1/2 base times height. Okay, well, it looks like here to here is 7 units, right? Well, that means if this is 7 units, over here is 7 units, but if this piece is 17, okay, that we calculated before, right, 17 minus 7 leaves 10 units for that piece right here. All right, and then again, if the radius is 9 feet on this side, the radius is also going to be 9 feet on that side. So it looks like our base and our height, okay, are going to be 10 and 9, meeting at that right angle. So let's plug this in. 1/2 base times height, and that's going to give us 45 square feet. Okay, the last is to find the area of the semicircle. Area equals pi r squared, but since it's a semicircle, we're going to have to end up dividing by 2. Okay, again, radius is 9. 9 squared is 81. Well, I'll break it up into 2 steps. So 81 pi over 2. If we want to, we can leave this in exact form. If we leave it in exact form, that's going to be, let's see, 81 divided by 2, that's 40.5 pi. Or if you want to approximate, punch this in your calculator. And it's 127.23 feet squared. All right. Last thing I need to do is find the sum of all of these areas. So 45 plus 153 plus 127.23, and I'm going to put an approximation because technically this is a rounded answer. And that gives us a grand total of 325.23 feet squared. Okay, if you need to, have Coach Baldwin pause this video and ask questions. Okay, backtrack to any of the steps if you need to. All right, if not, let's move on to example number 4. Okay, with this one, it looks like we have a semicircle, and it also looks like we have a triangle. Let's start with finding the semicircle. Okay, area equals pi r squared. And remember, that's the area for the whole circle. So for a semicircle, we're going to have to divide by 2. Okay, the diameter is 16, which means the radius is 8. Okay, that's going to be 64 pi over 2. Okay, well, 2 goes into 64 32 times. Okay, so simplified is 32 pi. If you wanted to give an approximation, punch that in your calculator, and that's about 100.53 square meters. Okay, next thing you're going to do is find the area of the triangle. Area equals 1/2 base times height. Okay, remember, base and height meet perpendicular. So it looks like we're going to actually have to draw the height into the triangle at a 90-degree angle. And I'll label this H. We'll take a look. My base is my radius, so 8. My height, however, okay, is the other leg of this right triangle. Well, we actually need to calculate the third leg, or the third side of this triangle, so let's use Pythagorean theorem. We can do leg squared, so 8 squared, plus the height squared, equals the hypotenuse squared. That's going to be 64. That's 289. When you subtract it over, and then take the square root as your last step. All right, so my height is 15, my base is 8. Let's plug it in. Okay, when I punch that on the calculator, okay, you should get that this is 120 square meters. Okay, and the last step is to total your area. So that's 100.53 plus 120. Right, that is approximately 220.53 square meters as my final answer. Okay, at this point in time, go ahead and pause the video. If you have any questions for Coach Baldwin, now's a good time to ask. I'm going to end this video and move to the second one for shaded composite figures.